We've completed creating our valid chain. Next, when we do valid chain, we want to check the length of the other blockchain and then verify. If this node is, for example, needing consensus, then we go to the other nodes and pull the blockchain's data and then verify here. For example, we have a scenario where we only have 2 blocks here. In our other nodes, we have 3 blocks. Then the 3 blocks are reliable, so this will be replaced with the 3 blocks. We're going to work on this section of resolve conflict. Previously, when we had our 5000/chain, we have chains here, and inside we have our block. Blocks will be displayed here, and that's the kind of API that we created towards the first half of our course. And with this, it's difficult to process the information, so let's make some changes here. And another thing, we have chains here, but chain might be easier to understand. So let's make these changes from now. First, we'll scroll up and find our blockchain Marshall JSON. Here we have chains. We're going to rewrite this to say chain. Now let's scroll up and find our blockchain struct. And in our blockchain struct here, I'm going to write JSON and write how we unmarshal when we want to do unmarshal. We want to create a custom unmarshal, so we're going to scroll down, and just like with our Marshall JSON, this time we want to custom our decode section. For this, we'll write blockchain unmarshal JSON. So here we're going to write a custom unmarshal JSON. Here we'll write struct, then blocks, and we want to display the content, so we'll write a pointer for a slice for block. Then the content will be chain, followed by passing in our BC chain. Next, we're going to be working on our error. We'll call on JSON unmarshal. We'll pass in %v address. Then if error isn't nil, then we'll return error. If there's no error, then we'll return nil. Regarding this blockchain, we're only doing unmarshal for the section that's chain. Once more, let's go to our blockchain struct. We're going to scroll up, and inside this, other than chain, we have mutex, neighbors, and other information. We don't need these right now, so that's why below we wrote only this for decoding for when we decode unmarshal JSON. Now, regarding our block, we want to do the same. We have our section for our block Marshall JSON. Let's write the unmarshal for this too. This will be b block unmarshal JSON, then followed by data, byte, error. For this, we'll use ampersand struct, followed by timestamp, int64, JSON timestamp. Next will be nonce, int JSON nonce. Then previous hash, string, JSON previous hash, followed by transaction, transactions, JSON transactions. As for the content, we'll have timestamp, b timestamp, nonce, b nonce. Then all there is left is previous hash. And if we place previous hash as is, then I'm going to scroll up, but our block's previous hash is 32 bytes. So we can't include this as is. We first have to place an empty previous hash string here, and we'll place that here for now. This will be previous hash here, which is what we just created. Next will be transactions, b transactions. At this time, we'll do JSON unmarshal, followed by data, v, and if error isn't nil, then we return error. And regarding our previous hash, we'll write underscore here, and then hex decode string. Then v, previous hash, and we're going to change this back to byte. We're going to copy this to b previous hash and then return nil. Now, at this point, we have data unmarshal, and when we are unmarshaling, it's empty here. We're changing this back to byte and then here, returning its own previous hash. With this, when we unmarshal and decode, the bytes hashed will be returned. With this, we've unmarshaled our block, so next we'll look at our transactions. We want to write the unmarshaled section for this transaction as well for now. Let's search for the transactions section in our code. And I'm going to scroll down and find our transaction section, which is here. Here we created Marshall JSON, so underneath this section we'll write func t transaction, unmarshal JSON, data, byte, then error. We're going to copy above and paste. We'll replace this line with v and struct and erase this. We'll include nil, so here include pointers, and include this symbol as well. Then if error, JSON unmarshal, data, v, error, nil. Then return error. If it's okay, then return nil. Now we wrote the section for decoding. Next, let's go to our valid chain section, and below this, let's add func bc blockchain. This will be resolve conflicts and return a bool. This is the method we want to write from now. Now let's look at our visual to the right. If against this blockchain node, we have a new block. There's already blocks in our port 5000 and 5002. We want to refer to the longest chain. So for this, we'll first write bar longest chain. First will come nil, followed by max length. And we want to obtain the length here. Here, we don't have any length. Then we'll make our index an underscore, followed by node, range, BC neighbors for our loop. Our endpoint will be fmt sprintf, then http%s, then chain, which is our address. We'll pass in node to this, and once we've created our endpoint, all there's left is to say http get and access our endpoint and obtain the blockchain information. If the response status code is 200, then it's fine. This time is the blockchain's response, so we'll write blockchain. Here, we'll write decoder and JSON new decoder. If we write resp body, then if we decode the information we got when we unmarshaled, we can obtain the information. We'll write decoder, decode, then BC response. We can pull out the chain, and this will be BC resp chain. This is private, so let's rewrite this. We want to make this public, so underneath our blockchain struct, we'll add on a func BC blockchain, then chain. Then we'll return block, followed by return BC chain. We'll go back to our code, and this won't be private, but a public chain. Once we've got our chain, then regarding the length of our chain, we have max length, and if this chain is longer than the very first one, then it's good. In addition, we have BC valid chain and place our chain. If this verification results in a success, then our max length will be our len chain. We'll be replacing, and then comes longest chain. This will also be chain. If we run a loop like so for all the nodes, then we'll be able to compute the longest chain. Next, we'll write if longest chain, and if it isn't nil, then the blockchain's chain will be the longest chain. Then let's also write a log. Log printf, resolve conflicts, replaced. We'll return true. And if that isn't the case, we'll write log printf, resolve conflicts not replaced. And we'll return false. If from this side, when the blockchain is received, then we'll verify if it's the longest chain, and in addition, verify if it's the correct blockchain. Then we'll replace the blockchain information. That's what we just wrote. And next will be consensus. When this node performs mining, then another block is created. At this time, this 5002 and 5001 will use resolve conflict and will pick up the blockchain data and verify.